So I think from last lesson you guys were doing a thing with question 3 and 5. I was just telling Nick might have to do 5 next week. It's a single lesson and we do want to just, move on and do some new stuff. But with 3, some of us who were a little bit worried by it, the bit that if I was drawing this, that I would do, I wouldn't make it so that the X and Y looked like it was evenly split. So I think they've been a little, bit nasty with the diagram.
Oh.
Not my first time. And I drew it too. When I drew my diagram, I had the A and the B right smack bang up the top, so it looked like that it was a diameter. So just little things like that help you see things that maybe, that's not good. Not making my point. So when I do something like that, I can sort of then not assume certain things, like it's not cut in the middle and all that sort of jazz. But anyway, we've got AX, C, Y, B. Okay. So that can move around. La 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 la. Prove that the triangle XYC has constant perimeter. So what is the perimeter? XC plus CY plus XY. And you go, yeah. And I go, what do they mean by constant perimeter? So basically, no matter where you put the X and the Y, where that's going, it doesn't matter if it's there or if it's sort of like that or in the middle, the perimeter of that triangle will be the same, right? So if I had, XY like that, this perimeter will be the same as that other one. Similarly, if I had it like that, then this perimeter would be the same as the previous one, etc., etc. Yeah? So you sort of want to have an idea of what the question is asking you rather than just going in willy-nilly. But before we go, what do we notice? Well, what do I see everywhere? I see tangents galore, right? And I see a tangent here, which means that and that is the same. It means this one and this one are the same. And it also means that the outer AC equals BC. So I've got, might do that over here, AC equals BC, AX equals, did it say where it met? What do you want to call that? Woo, it's already got Y. I'm going to go Z. Okay, so AX equals XZ and BY equals ZY, or should have gone YZ, alphabetical order. So go, yeah, okay. So if we now look at the perimeter, what on earth is going on there? So we've got XC. Could I get an expression for XC? Would you agree with me? And this is the bit where you might not have thought to do this. I've done a few of these in the past. So when I'm telling you, do you consider? This is me giving you some hints. So maybe next time you see a question like this, you might think, hey cards, this is an option, right? So if we look at XC, would you agree that that is AC minus AX? CY and do you know why I'm doing this? Because some things should sort of cancel out, because it's sort of saying, when I've got these equaling, now what I'm thinking is maybe AX, I might have an AZ somewhere, I could cancel it out with something somewhere along the line, And here it comes, because XY is, what is XY? XZ plus ZY. So that's going to be plus XZ plus ZY. Do we agree? And we go, well, hang on. Let's see about this. I've got AC take AX plus BC take BY. And when I've got this XZ, what is XZ? Isn't it the same as AX? Ooh. And isn't ZY the same as BY? And that means that this one and this one cancel, this one and this one cancel, and I'm left with AC plus BC. But what do we know about AC and BC? They're the same. So that's actually 2 lots of AC, and that is going to be constant no matter where you move the doodads around. Does that make sense? Stop, I'll stop. So with this one, what have we got? Would that be right angle? That would be right angle. That's common. This is a tangent too. So, which means that's right angle and that's right angle. So I see 3 similar triangles. Do you? Yeah? So, what should we call that? C? Q, C, P, Q, A, R, Q, B, S, Q. They're all similar triangles. And hopefully, as I said, I haven't done that one, but hopefully that comes out to be, what is it that we're trying to get? Hey? You can't? You can. That's a can or a can't? Can. Oh, well, if we have time, would you mind coming up and showing your method? That would be nice. I just want to flash up, and you've got these on your theorems, so you don't need to write this down because it's all on your theorem sheets. But cyclic quads, come on. I just said it's on your sheet, so you don't need to, but yeah, so you can have a look at this, and if you want to write it down, you can. If you don't want to, then you don't have to. Hello. So, cyclic quadrilaterals. Basically, a cyclic quadrilateral. Oh, I am on fire today. Seriously. Yeah. But I ruin it with curvy straight lines. Damn it. Never mind. So, basically, if I can draw any 4-sided figure inside a circle, some groovy things start to happen. And the most grooviest thing of them all is that the opposite angles always add up to 180 degrees. Archie! Now, Archie. Right, so the amazing thing that happens is that the opposite angles add up to be 180 degrees, right? And you can do this conversely. So if you happen to have any old 4-sided figure, Bronze, we're listening? If you have any 4-sided figure and it ends up being proved, you can prove that that plus that equals 180 degrees, then you can say, haha, it is a cyclic quad. All right? So, do you go this way? If it's on the edge of a circle, they tell you it's a cyclic quad, you can assume, bang. If you want to prove something is a cyclic quad, then you have to prove the opposite angles add up to be 180. Seems easy? Yeah, but we're just saying, so you could get one of this and it's in the circle, right? And you go, or they tell you it's a cyclic quad, bang, you assume opposite angles add up to be 180. You might get questions where it says, prove that it is a cyclic quad. Well, then your proof is you have to show that the opposite angles add up to be 180. So it's that one. And a friend, I think that you've seen before. Oh, it's a little bit lower now. Might not be a good circle. I've set the bar a bit high. It'll do. We'll try it. No, I can't redo that. Anyway. So if we have our cyclic quad like so, if we end up by showing that this is the case, no, that's not good. Where have we seen that sort of before? Bow tie, angle subtended by the same arc, right? If you can show that, that is also a match for cyclic quad. And again, going back and forth. If you can prove this, it's a cyclic quad. If they tell you it's a cyclic quad, then you can assume these opposite angles are equal. Does that make sense? Right? Because they're going to ask you to do some fundamental groovy things to begin with. So, did we have any? I forgot to ask any questions from this one. You'll see it all comes together. Like I'm not really phased that we don't do every single question, and it's not a matter of some are really hard. I'm skipping them. For you, it's just time. You can't do every single proof. Again, very nice. If we had time, we'd go through. They're proving it. That's lovely. There they go. See, haven't lied to you. There it is. It should be on your printout if you see it somewhere. Have you found it on your printout? Have you? Yes. Do you want to start with number 1? Yeah, let's do it. Warming up. Oops, wasn't recording that whole time. How embarrassing. But there's the proof. There you go. You're all here. I don't know why I'm recording. Who's away? Oh, Kev. Sorry, Kev. I said everyone's here. I was going to say, I just said everyone's here, and then somebody said, is anyone away? I'm a bit worried about their deductive skills. But someone was away, so I cannot say that. How would you go about proving number 2? We won't do it, but how would you? What do you see with number 2? Lots of triangles, and then we want to go, is it a special type of triangle? Isosceles. Why, Kate? Right, we've got radius, and as soon as we do that, yeah, so because we see center of the circle, we go radius all over the place, so we'd go dash, 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 which means if that's A, the other side is A. If that's B, and so on. And then what do? You could add them up. Where does it equal a right angle? It's not splitting it. I think what you'll end up doing is saying that A plus B or whatever equals 1A because you have them equaling, and the opposites end up equaling. It's all right. You'll do it. It's fine. We can skip it. Number 3. It's insulting because how would we find X? Right, it is a cyclic quad, so we just go 180, take 73. Let's not even bother. Right, what about this one? 1x plus 2x equals 180. Therefore, 180 divided by 3, you'll get x. We're all good with that. Moving along. Can we just go, that plus that equals 180? No, it's the opposite sides equal. So, what's the trick with that one? It's not really a trick. It's what do you need to observe? There's something on the diagram. Parallel. That's good. So what does that mean if they're parallel? Co-interior. So that means that this angle plus this angle adds up to 180. And the same as that one plus that one equals 180. Now, that's going to make me nauseous trying to work that out. Whereas here, I could just say that that angle is, in terms of x, 180, take x. Do we all agree? Now I can write my expression or my connection, my equation, that that plus that has to equal. Why? Because it's a cyclic quad. So I would say angle ADC, 180, take X, allied, you can say co-interior. I refuse to convert. Therefore, 2X, take 70, plus 180, take X equals 180, cyclic quad. And you should now be able to solve that. Yeah? Moving along. Let's get into, these are the ones I think you like. What? 2X, take X, is X. 70 on the other side. Always ask if you're unsure, please. Anyone? Bueller? What would this angle be? X, Y, 180 degrees in a straight line. This is now stuff we already know. Correct? Bronze, we're right? X, and so therefore X plus X has to equal 180. What would you comment about that diagram? Yeah. X is meant to be 90 degrees, so not drawn to scale. Don't look like 90 degrees to me. Okay. All right. I would ask you, I will stop for a minute. Try E. And remember, the things that you need to look at, what's important there. So what would be key? Is the center shown? No. So all of those rules, what's key? Go look at those theorems. See if you can do it. Applying this is the same as this. So straight away we should go, well, that's 47. You should also be able to tell me what this angle is. Pardon? That is not 109. I disagree. 180 take 109, so that is 71. Well, how does that help you find X? Where's vertically opposite? I think you mean it's a straight line. So that plus that plus that add up to be 180. Don't say vertically opposite. Vertically opposite means that. I hear you. But you still have to go 180, take that. So why don't you just, yeah. Okay, got it? But again, what was the technique you were using? Look at the diagram and see what is it that's there. Right? Don't assume parallelity. But you saw the tangent. That was key. Look at the theorem. You saw cyclic quad, hopefully. Use them. All right. We're whizzing through. With question 4, explain to me how you would go about doing it. Is ABCD a cyclic quad? Explain your answer. Yes. Yes, so this one. If you add them up, they equal 180. We go, huzzah! It's cyclic quad. If it doesn't equal 180, oh, no, sorry. You can't come to the cyclic cyclic quad party. So, do we agree? Yes? Do we agree? Huzzah! Do we agree? No invite for you. Do we agree? Do we agree? Yes. 180, take that, gives you that. Therefore, they have to add up. What about this one? A. Which one? A, B, C, D. Whoops. You're saying no? Yeah, but it's not joined together. We could join it together. Yes, ask me. Number B? How did I know? Crisscross. That's the second property of a cyclic quad. So if we go back, and this is on your theorem, so you should have it written. Cyclic quads. Let's have a look. They're looking at me blankly. Hello there. Okay, back we go. So, why do we say this is or isn't? Well, that would be 80. Would you agree? So that means, Yep, what's that one? We can go that. What's that? Hang on, we're getting there. What's this one? 65, I agree. You should be able to tell me what this angle is. Why? 360. And therefore, once you've found that, you should be able to find this angle. Yes? 180 degrees in a straight line. If it equals 65, then ABCD is a cyclic quad. If it doesn't, no, it is not. It's on the reject side with C. Yeah? Again, how we go about sussing, how do we answer a question? How do we say if it is or isn't a cyclic quad? You've got those two things. If the opposite angles add up to 180, or you've got this angle and this angle equaling each other. Capiche? Let's do one of those worded problems now. And when I say let's, I don't mean me, I mean you. What do you reckon? 5 has no diagram. 6 has one. You want to do 6 then 5 or go in order? 6 and 5, bad luck. Those who want to go in order, then you do it. I'm going to chill out for a minute. Let's go. So, can you talk us through this question?
Yeah. Oh, okay.
Go. You got to have it right to you.
Oh, okay. So, you know that OABC is a parallelogram, and we need to prove that DOCB is a cyclic quadrilateral, so I'm just going to draw a line. So then, because OA is the radius of the circle, and OB is also the radius of the circle, because they're both touching, like, at the ends of the circle, so it's isosceles. And then...
And this is when we went, we have to prove that it's a cyclic quad, so you need to go, well, how do you prove that? And we said to prove it's a cyclic quad, what did we do? You got to point with the pen. Yeah, opposite angles.
These two angles need to equal 180. Yeah.
So start with calling one of them something. Now you could start with the top one and work down, or from the bottom and work up. Let's go with the top. So
okay.
We stick an alpha. Then what?
So to prove that OCB and ODB are... Okay. Yeah. So to prove that this and these two angles... Oh yeah. Yep. Are 180.
What do we see?
Yeah. Oh, yeah. Isosceles, so this is at alpha. And then if we look at angle OAB, DB is a straight line. So we can say that this angle is 180, take alpha.
And I'm just going to stop you there for a minute, because what you need to also know is then, tell them.
Yeah. We need to look at the properties of a parallelogram. So, yeah.
Yep. So opposite angles.
Opposite angles. So equals each other. So that means if this is 180, take alpha. This means that this is also 180, take alpha. And to prove that these two...
No, you're done.
Oh, okay. 180.
We're done now, because we can see that... May I borrow that? We can see that these add up to be 180. Yeah. And may I just say that you draw your alphas funny, because that looks like the OC, right? Alpha.
Sorry.
That looks like a TV show. Anyway, so try and work through. Thank you very much. That was excellent. Yeah. But the main thing is you must look at your theorems, okay? When it says parallelogram, that was the key. If you didn't know that they were opposite each other, you'd be there for ages. Keep going. Good luck.